Chapter 6 Benzene and its derivative. Introduction. Aromatic hydrocarbon or arenes are hydrocarbons that contain rings which are stabilized by electron delocalization. Benzene is an example of an aromatic hydrocarbon. The criteria for aromaticity. 4 structural criteria must be satisfied for compound to be an aromatic. First, cyclic. Second, planar. Third, completely conjugated, means that alternating single and double bonds, and contain particular number of pi electron or obeys Huckel's rule. Obey Huckel's rule. The compound that's cyclic, planar, and completely conjugated that contain 4n plus 2 pi electrons, which is n is equal to 0, 1, or any positive integer, are considered as aromatic. The planar monocyclic rings with 2, 6, 10, 14, and so forth pi electrons are aromatic. For example, aromatic compound with a single ring, benzene. To apply Huckel's rule, first, count the number of pi electrons in the molecule. In benzene, it has 6 pi electrons. Then, set this number equal to 4n plus 2 and solve for n. For benzene, we find that n equal to 1, which is a positive integer. The rules is met and obey Huckel's rule. Benzene is aromatic because it contains 6 pi electrons or obeys Huckel's rule, cyclic, planar, and completely conjugated. Next, we refer to the second example, aromatic compounds with more than one ring, naphthalene. First, count the number of pi electrons in the molecule. In naphthalene, it has 10 pi electrons. Then, set this number equal to 4n plus 2 and solve for n. For naphthalene, we find that n is equal to 2, which is a positive integer. The rules is met and it obeys Huckel's rule. Naphthalene is aromatic because it contains 10 pi electrons, which is obeys Huckel's rule, cyclic, planar, and completely conjugated compounds. Kolej structure. Kolej suggested that the carbon atoms of benzene are in the ring, bonded to each other by alternating single and double bonds. However, Kolej structure can't explain why benzene molecules are not undergoes addition reaction. Resonance structure. In 1930s, Linus Pauling introduced the concept of hybrid orbital and resonance. The real structure of benzene is the resonance hybrid from two Kolej structures as shown below. In benzene ring, the carbon atoms is sp2 hybridized. The 6 pi electrons completely delocalize around the benzene ring. All 6 carbon atoms and 6 pi orbitals are equivalent. The circle represents the 6 pi electrons distributed over the 6 atoms of the ring. In benzene ring, the electron delocalize around the benzene ring. Arenium ion. Arenium ion is the carbocation ion or the intermediate formed by the electrophile attack on aromatic ring. Benzene ring attack the electrophile and produce an arenium ion. Electrophile takes 2 electrons of 6 pi electrons system to form sigma bond. This interrupts the cyclic system of pi electrons, so the benzene ring, which is aromatic, will form an arenium ion which is non-aromatic. In arenium ion, the 4 pi electrons delocalize through these 5 carbon atoms, p orbital.